narrow band FM. So what is the condition for narrow band FM? In that reference equation, we have to choose beta value much less than 1. Okay, then the reference equation, FM equation S of t is equal to AC cos 2 pi FCT plus beta sine 2 pi FMT. Now this formula is like cos A plus B. So this term I will consider as A, this entire term as B. That means cos A plus B formula. Just expand with the cos A plus B formula. So AC cos A plus B is cos A cos B minus sin A sin B. So cos A cos B, cos A cos B, cos A cos B minus, again that AC is common, so that's why I am taking here also, cos A cos B minus sin A sin B, sin 2 pi FCT and then sin beta sin 2 pi FMT. So now if beta is much small, okay, please observe carefully, if beta is much small, definitely this quantity will be much small because sin maximum value is 1. If beta is much small, then entire value will be much small, approximately equal to 0. Then cos of 0 is almost, it's like 1. Cos of 0 is 1. So that's why this term I will cancel. Only I will write AC cos 2 pi FCT. Okay, instead of this we have to put 1. Okay, then next minus AC sin 2 pi FCT. Okay, when beta is much small, beta sin 2 pi FMT is also small. Sin of theta, if theta is very small, sin theta is equal to theta. Sin theta is equal to theta when theta is small. So that's why I will write only the theta component. That means beta sin 2 pi FMT. So why I am writing like this? Sin theta is equal to theta if theta is small. If theta is small. Okay. So now I got some expression which is somewhat similar to the AM equation. Now I hope, except this minus sign and beta. So in the previous case we got mu. In case of AM, so once again I will rewrite this. AC cos 2 pi FCT minus AC beta sin 2 pi FCT sin 2 pi FMT. Again, now also you can apply the formula sin A sin B formula. Sin A sin B is equal to cos A minus B minus cos A plus B. Okay, so I will apply that formula. AC beta by 2 cos of 2 pi FC minus FMT minus AC beta by 2 cos of 2 pi FC plus FM. FC plus FM. So now I will apply that minus for both the term. So this term will become minus, the next term will become plus. So finally, the narrow band FM equation is AC cos 2 pi FCT minus AC beta divided by 2 cos of 2 pi FC minus FM into T plus AC beta by 2 cos of 2 pi FC plus FM into T. Now you can refer the AM equation. Once again, I will write the AM equation here for your reference. That is AC cos 2 pi FCT AC mu by 2 cos of 2 pi FC minus FM into T plus AC mu by 2 cos of 2 pi FC plus FM. Now you can compare with the AM equation. So now this narrow band FM is almost similar to AM equation, except that plus sign and minus sign. This is narrow band FM. So here we are getting minus, but here plus. Instead of mu, we are having beta. Mu is a number. Mu is a number that is indicating the modulation index in case of AM. Similarly, beta is also a number that is indicating the FM modulation index. So that means what is the final conclusion? The narrowband FM is somewhat similar to the AM. Okay, how it is similar? Okay, now we will draw the spectrum of the narrowband FM spectrum, narrowband FM spectrum. Here we are having carrier. So carrier will be present at FC with the value of AC by 2 once if you write it in the frequency domain. Again, we are having spectrum at the positive side. That means FC plus FM. So at FC plus FM, we are having spectrum that is AC beta by 4. But at FC minus FM, we are having spectrum with the negative value. With a negative value, that is AC beta by 4. That is the only difference. Only the lower spectrum will have the sign change as compared to the AM spectrum. The lower spectrum will have the sign change. That is the only difference between the AM spectrum and the narrowband FM spectrum, NBFM narrowband FM spectrum. அதாவது எஃப்சி மைனஸ் எஃப்எம் மட்டும் அதனுடைய ஆம்ப்ளிடியூட் ஸ்பெக்ட்ரத்தோட ஆம்ப்ளிடியூட் வந்து நெகட்டிவ்ல இருக்கும். பட் இன் கேஸ் ஆஃப் ஏஎம்ல அது வந்து பாசிட்டிவ்ல இருந்தது. இதுதான் வந்து மெயின் டிஃபரன்ஸ் இன் டர்ம்ஸ் ஆஃப் ஸ்பெக்ட்ரம். அகைன் அண்ட் ஆல்சோ வாட் இஸ் த பேண்ட்வித்? It may be negative, no problem, but still the bandwidth remains same. So 2 FM, bandwidth of the narrowband FM is 2 FM. So that's why ultimate final conclusion is narrowband FM is almost equal to the AM system. Almost equal to the AM system. That is the final conclusion. So we started with the frequency modulation basics. Ultimately, we got some expression, okay, by taking message signal as AM cos 2 pi FMT. Ultimately, we got some message signal. Ultimately, we got some expression for S of t, modulated FM signal. Then we have defined what is beta. Okay, then if beta is less than 1, okay, much less than 1, then that is indicating the narrowband FM. And also it is resembling the characteristics of AM system, both in terms of bandwidth and